So, for the next slot, we have a panel discussion. As already mentioned a few talks ago, Christoph Strnadl is the first panelist I want to introduce on the panel. Christoph Strnadl from Software G. Do we have? Perfect. Christoph, it's a pleasure to have you again on the stage.
Yeah, thanks.
The second speaker from our panel is Dr. Valeria Bartsch. Dr. Valeria Bartsch is working as a team lead for quantum computing at the Fraunhofer Institute for Technology and Economics within mathematics in this context. So please have a seat over there. And finally, our third panelist is Dr. Johann Schmidt. Dr. Johann Schmidt is working as a scientific advisor for the Projektträger from the German Center for Aerospace.
Where would you like to have me? Thank you.
So, and finally, what is the question, or what are the questions we are discussing today? So, the panel discussion has the title "Quantum Computing: A Renaissance Opportunity for German Software Industry." You already touched a lot of points, Christoph, in this context. And in this context, my very first question to all of the three of you is: we think we've discussed a lot the ongoing technological challenges in building scalable quantum computers from the hardware perspective, but really making the deep dive in the software layer. What role does software and algorithms deployment play in reaching quantum advantage sooner in the next months and years, maybe? So maybe, Valeria, do you want to start with your view or perspective on that? Which role does software play, and what do you contribute there in this context?
Well, I think, I don't know, like, can you hear me? Oh yeah, now you can hear me. All right. Okay, so I guess we have heard it all today, right? I mean, we have seen that a lot of the acceleration, like when a quantum computer can actually have an advantage, comes from software. And that is clearly an advantage here. But then, of course, we have to rethink that it's not all about software. I mean, like, we can't get anywhere just with software. We have to have the hardware there, and it has to be a co-design effort. We need to include both hardware and software, clearly. Yeah.
So it's a lot of integration in the future and developing skills, developing knowledge in the software field, also in the integration layer.
Yeah, I think that we need to develop skills, but it has to be, we have to be very specific what skills we need for which stage. I mean, like, because I think that right now people have to do a lot of things still in software development for quantum computing. However, I believe that there will be a specialization in the future, because I believe that there will be middlewares coming up which will hide a lot of the complexity that people have to deal with right now in the future. And therefore, we will have special roles in software development, and here we have to kind of focus on. Yeah.
Thank you. So, Mr. Schmidt, what do you think? What is your perspective on the role of software in the quantum development?
I think it's highly essential because you talk about quantum utility, quantum advantage. It's a very interesting theoretical concept, but I think what matters in the end is a business advantage to get from quantum computing, from quantum advantage. And to get there, you definitely need software, because you can't just put a quantum computer in the basement of your company, then you have no profit from it. Instead, you need to implement that quantum computer into your existing services. You need to have software that connects the quantum computer to whatever you are already doing now. We just heard from the SMEs that say, we have a product that we sell, we have a running system, and they don't want to drop that and do something new. They want to implement the quantum computer into that system, and that is software that is needed there. And I agree, a lot of the complexities need to be hidden, and that's software can do that.
Thank you. So, Christoph, you already presented a lot of insights and thought in this context in your presentation, but what do you want to add into the considerations?
Yeah, the only add which comes to my mind right now is that the software value creation will not take off as long as we see a necessity to have hardware and software co-design. To the extent that the software development is tied to specific computing models, topologies, etc., it will remain a flat growth. Growth, yes, but it will be a flat growth. Only at the point in time where software development is completely decoupled from the underlying hardware, high-level languages, I'm not talking about Qiskit, maybe even on a higher level, then we will see exponential growth in software, in the software value segment.
Yeah, but this I also think will happen. I mean, this is this specialization of roles, right? I mean, can only happen when you have this middleware, which is actually doing a lot of this.
That would accomplish this decoupling, exactly.
Yeah, exactly.
Yeah.
So, Valeria, you already touched a little bit on that layer. I want to focus now on is really about the integration, the integration between the hardware world and the software world. Which challenges do you see, and how can they be really managed in concrete cases in the future, and how can we get ready for this, and really some insights maybe about concrete programming languages and concrete problems which can occur in the future?
Well, I mean, what we see, at least with gate-based quantum computers, is that there are now quasi-standards evolving for APIs, such as OpenQuasm, which people talked about, and you might need for the hardware interfaces also additional information. But where there is a potential for chaos again is when you go away from gate-based, and actually, I don't know, like maybe it's just my hobby horse, but I quite like those simulators, and I quite like those systems which are a bit more crazy, because they might actually be a pathway which is quicker towards quantum advantage. And once you go down that way, then suddenly you're going away from these standards again, and need to define other standards probably, and that's really an unknown at the moment. But I think that there is a point where things are developing, at least for gate-based quantum computers, into standards. So yeah. This is already good.
Thank you. So next question is to you, Christoph, really about market opportunities. So you are a software AG, you are a software company at some point, which already the name says, I would say. But what are the business potentials you see for software AG in the next years, and how do you get ready to leverage them?
Our position in the software, in the quantum computing value chain is quite limited. So we really focus, and we have been focusing since the last 20 years, on integration. So we will never go into, most probably, we'll never say never, but we will never go into quantum computing algorithm and software design. But for the other companies who do that, I mean, I'm a theoretical physicist, so in theory I could do that, but I'm not allowed because I have to sell gateways and API microservices, whatever. What is linking everything? But the real value is in the future quantum SAPs, in the modules which are solving in the module where you can buy a plugin for SAP, for Salesforce, which is optimizing your price bundle for an airline, or solving the gate assignment problem. And this plugin, whoever is developing this plugin, they will come to us and say we need to integrate it, probably, hopefully, or we partner with them. But the value will be generated by the information you get out, by the decisions you get out from the quantum system, and that's in the software. So the key task right now seems to me twofold. First, you have someone on the business side who understands at a deeper level the business problem, and then you have to have another person who is able to map that and to extract the quantum computing stuff, let's say, to put it more in a better wording, those parts of the business problem which may be solved in a better way using quantum algorithms. Someone has to identify those. You need a quantum algorithm business analyst, something like that. And those two would work together, and then you go down to the middle where you develop the topology, the algorithm, and then you go back to software chain, let's say, who implement me the interface or whatever. But so these two roles will be required in our way. And whoever is there first will earn most of the money, because that's a winner takes all, like in ERP, because maybe the second for other quality reasons or so. I don't like your color of your logo, but the first two will take away the vertical solution and will take most of the market share. This is my deep conviction. We've seen it in other markets.
But now you've left out the role of software AG, who's also trying to make money there, because I think you need that.
We sell the integration stuff to all
exactly.
the two.
And I think you need that person as well. Because once
we
you
are happy
have
with
the two people who identify it, then they can't go to the person who says, like, I'll implement the circuits for you. We need to have this middle.
Right, yeah, we are happy in that position. Yeah.
So as we have learned, as you summarized it perfectly, software does not want to really develop a lot of software. Maybe the question addressed to you, which potential do you see for startups maybe in this field, in this domain, or which companies do you see to be the players in the software ecosystem, which we also need to see to grow in the next years?
Yeah, I think it's a great opportunity for startups. Of course, you have big companies driving this forward, sort of internationally. You have the big names, Google, IBM, Microsoft, etc. Also in Germany, you see the Q-Tech forming. That's the big companies. They are the ones that are not out there in Baden-Württemberg thinking about, I don't have the money to do it. So they push this forward, but sort of they could drive from the top. And from the bottom, I think you have a great opportunity for startups, because they're very agile, they have innovative ideas. They also bring together the different perspectives that you need, sort of the physicists, the computer scientists, the engineers. So they have a huge opportunity to drive this topic forward.
We also have a lot of funding programs from German government where US DLR are heavily engaged. Which role do you see in this public-private world?
I mean, we heard Anna Christmann earlier today on the stage. She was very strong about sort of supporting startups, and I think the whole federal government backs this up. They have a startup strategy which identifies that support has to come from many directions, right? You have financial support, you need to create the right climate, you need to create sort of legal support, etc. So there's many different tools that have to be used by different actors to support these startups. In our daily work at the project management agency, DLR Projektträger, we fund consortia that combine research institutions and companies. And we sometimes have a hard time funding startups because of the rules and regulations that we have to follow to make sure that everything goes smoothly and so on. So we have tools. Sometimes we can fit a square peg through the round hole if we just hit it hard enough with our hammer. Sometimes it's maybe not the best thing to do. The Projektträger also has ideas. So just recently there was a discussion paper published by the network of project management agencies, which the DLR Projektträger is part of, on how to sharpen the innovation tools that we have to maybe support startups a bit better in the future.
And maybe one follow-up question. In your opinion, how good is the world of the hardware funding programs connected to the software funding initiatives and programs? Are they linked good, and is everything fluent and integrated as we need to integrate it in the end?
If I say yes, would I be lying? So, of course, I mean, this comes with many actors and many different tools again, right? So many people are working on different things. Many people are speaking to each other on many different levels. So on the working level, I mean, you have the same people active in different fields that are talking to each other. At the project management agency level, we speak with each other and have exchanges there. And in politics, I think everybody will tell you that they're open to discussions and they're speaking with things together. It's just sort of, I think, the structure that this innovation landscape is structured in Germany. We have a federal system, we have different people active, so it's very hard to really sort of like put everything in one place and pull on one.
Information sharing is key. So to have transparency what is happening and to...
Exactly, and that, of course that can always be improved with that many people working together, but I think we're already doing a quite okay job.
Thank you. So next question is addressed to you, Valeria. It's about, again, the integration of the hybrid world, the hybrid future world we will see. So from your perspective, where do you currently see the biggest challenges in combining the classical computing world and the quantum computing world, especially in the context of software? So how do things connect to each other, and how can we manage the two worlds in parallel, and also the integration between the two layers?
Well, at the moment it's working somehow, and of course they are great. You know, like it's great that it's working, but still, we are a bit wasting compute times on both sides, and this can be integrated closer, because I believe the same thing as Christoph, that quantum computing is basically an accelerator to high performance computing, and in that way you can use the whole tool set that's out there for HPC. It doesn't have to be something extremely special here for quantum computing. And in the long run, I believe, I mean, because currently we still see a lot of cloud access with the systems, but in the long run, I foresee a more tightly coupled system where you can actually start to think about approaches which are much closer to parallel computing, really, and just treat the quantum computer as another accelerator, really, here. Yeah.
Thank you. Thank you. So the next question I would like to address to both of you. It's about the software programming paradigm or evolution, one could say also. What kind of strategies and training initiatives are needed to prepare classical developers to the quantum world? So you already said that you're not planning to invest too much in software development, but maybe you also have a perspective on that from your personal experiences and thoughts, but also from company's perspective.
Yeah, I have a very heretic question to ask. Why do we assume that classical software engineers, the Java, Node.js, Python guys, why do we assume that those skills are the best suited skills to do functional programming on a single state comprising an n-dimensional complex vector, and the functions you are allowed to use are just unitary matrices? I forgot the complication, you can't store it. The matrices, the result is not deterministic, so you have to repeat your algorithm a lot of time. And the functions, you cannot really specify them because you have to decompose them into kind of weird two-level gates. Why do we think a classical software engineer would be the best one to solve that riddle? Physicists are accustomed to that, mathematicians, maybe electrical engineers. So maybe it's like software engineering. Software engineering guys in the 1950s were electrical engineers, and actually many women. If you look at the Apollo program and others and ENIAC. So because you needed a new skill set, maybe we should go really outside. I do not doubt that many excellent software developers will be able to grasp functional programming. I did that in Wolfram 10 years ago when we didn't have Erlang, etc. It's write once, read never. That is the same for the current QuizKit code. So, but you can master that, but it's not necessarily software engineering. Maybe we need a new form of quantum code developer, co-developing and evolution with the middleware development, etc. So I would say.
Maybe one direct follow-up question: where do you get those talents from?
University. Yeah,
Also
university dropouts, by the way. Sure.
But why don't you think that people who are currently studying computer science couldn't be in future be trained to be quantum computing developers? Because I think that's possible. I mean, I'm seeing it, and I think it's possible.
I don't doubt that it is possible. I doubt, or put the question out here for us: are these the right kind of skills as a basis? Because they are trained in sequential, in list programming, in other paradigms. You look at Java or whatever, and they have to completely. I have been doing quantum computing calculations by hand. It's completely different. You cannot use any of the old paradigms. Of course, you can unlearn that, but why not start a parallel way, or I don't know, a bimodal software quantum engineering, and you see who drops out? So I'm not totally against. It was a heretic question, you understand. But I think that the thinking is completely weird. It's no one. Quantum logic is completely different from propositional calculus. You can't compare that. But if you do that for 5 years, you get the kind of we got the Nobel Prize with Zeilinger. So if you do that for 20 years, you get a neck on it. So you can solve quantum problems in your head. So if you think in qubits and unitary and Hamiltonian operators, but it takes time.
So Christoph, we should do a challenge. Like 5 years from now, we will have a look who is actually then the quantum computer engineers, and then I don't know, I don't know. I'm
Bottle of
coming.
champagne, yes.
Yeah, I'm coming from Pfalz, so I would think about wine, but.
Oh yeah. Okay,
Yeah,
we can have
okay.
a wine contest.
All right.
I come
Okay.
from,
Yeah, we do that.
Also,
Okay.
we do that, yeah.
I find it a very interesting question, though. But one thing you mentioned is, right, you put in the unitary matrices by hand, and you do this now with a few qubits and a few gates. The question is, what happens when you have millions of qubits, fault-tolerant qubits, and you want to implement Shor's algorithm, right? So I think, sure, you can never drop completely that this is a quantum computer now compared to a computer, but I think what needs to happen to answer this question is you need to develop sort of like, I wanted to say take quantum computing programming away from the physicists, but then we have 3 physicists on the stage discussing about quantum software, so I don't want to say it anymore. But you need to develop sort of like these higher level languages. You need to make it sort of like easier for the classical software engineer to program the computer. And I think, or at least sort of like that's something that we try to fund as well with our funding programs that were just up on the screen. So there's clever teams out developing new compilers, developing high level languages that sort of take away a lot of the dirty work and automate a lot of things. So I think that's very essential.
I've one remark to that. In principle, I agree. Maybe we find some intelligent middleware, AI-based middleware. It will be very hard because there is a theorem out there that says if you want to achieve exponential quantum speed up, and the larger your qubit state, then the more qubits you have, the more you need to involve entanglement, the least understood of the properties of quantum systems. So someone need to provide that entanglement to the algorithm. And for the next 10 or 15 years, maybe that will be humans. Maybe in 25 years, it will be chat AI, GPTQ, something like that.
So I think what we learned from the last considerations is there's a lot of uncertainty and a lot of strategic
opportunities
in navigation. So keeping in mind uncertainty, we have a lot of uncertainty also on the hardware layer. So we have an uncertainty on the hardware layer, which technology stacks will succeed, which will not maybe, or which will be useful for specific applications. So how can we navigate this complex world, starting with you, Valeria? How can we make decisions about where to invest money? Both public and private money.
I have to start? Oh dear. I have to tell you where you need to spend money. Oh my God. I mean, this is really, really difficult. I mean, like.
Make a wish.
Yeah. I mean, I don't care. In principle, I don't care about the hardware. I mean, what I care about is that we have really good qubits, that we can work with them, and that they are really nicely connected. And that the errors are not completely crazy, and that's basically what I want. And whoever gives me that, I mean, I'm happy. I mean, like, I don't even care.
Totally independent of hardware.
Well, I mean, of course, there are different. I mean, as I said, there are different programming paradigms. For example, if you go to photonic, then suddenly things change a lot. If you go for Rydberg atoms, suddenly things change. People have simulators and stuff like this. I mean, and this means more effort for us. But if we stick to gate-based, then there are few features which we want, which we need to program. But basically, who gives us that? I don't care. I mean, I don't have like that. I say I have to have ion traps. Of course, they are great and all this stuff, but they have advantages and disadvantages. But like there are certain features, like how fast are they and all the stuff which we care about. But the real hardware, I mean, like whatever is best, right? I mean,
So we generate a wish list, and then we can do the possibility to answer.
Yeah, I have one recommendation for the wish list. I think the Cyberagentur did a nice job by not limiting themselves to a single hardware foundation. I think that would be wise, not to put all the eggs in one basket, but look into all of the technologies. And strategically, I would also reserve a little bit of money for technologies which at first sight are completely unlikely to succeed. because disruptive inventions, also in quantum technology hardware, you do not see them coming. And if we do incremental research, we end up with NV centers, photonic, quantum brilliance with the diamonds. They are all known, but how do we discover the unknown technical substances? And we need to reserve, or I would recommend, we could reserve a certain portion. And even if someone handpicks that and we do not have a real evaluation because he finds the guy nice, the lady nice who is putting forward the proposal for the unrealistic, for the low probability things, because maybe there you have a real Sprung-Innovation, a real disruptive innovation. You don't see them coming.
Yeah, the right to failure is important. It's something that's not in our culture, but we should have the right to fail. I mean,
having spent some money on that failure.
Yeah, exactly. We should try out some approaches. Also with software, the same thing applies. I mean, open source software develops also that there are, competitive approaches often, and one of them wins. And it might not even be the best. It might be the one that most people are using. But still, I mean, this is a right to failure, which we in Germany don't seem to have, and that's a bit of a shame. Yeah.
Can I tell that my CEO?
Thanks for that wish list. I'll take it with me and talk. But I mean, a lot of these things have been taken up. Right? If you talk to my colleagues from the Quantum Computing Initiative, they're funding a whole number of different platforms. And I think anyone who says like this is the platform that makes,
I don't see a real problem. Yeah.
Is lying to you. But I think we should put sort of a lot of the baskets that we eggs that we have that we can put in baskets, which we get from Christoph Flock and his unit. We put a lot of these eggs into the software basket. Because many different platforms are there, we don't know which one wins. So maybe we can use software to sort of like bridge them a little bit. If we think about such a platform such as Planck that we funded from in the past years, then one idea of Planck is to sort of like have many different backends available and sort of hide it to the end user, because the SME doesn't care. They don't even know what trapped ions are.
I would fund that middleware as well, yes. Quantum computing abstraction layer.
Yep.
So maybe one question addressed to you. So when we think about partnerships between the ecosystem actors from hardware and software side and perspective, which collaborations do you see and which partners do you see, and which do you not see yet, and which should evolve in the next time? What's your perspective on the current status quo?
I'm going to take a bit of a narrow view and focus on the things that we have that we fund and that we have under our control in this program, Quantum Computing Applications for the Economy. As it's mainly a software-driven program, we have a few collaborations. So we have Electron, which was very active earlier today, that are part of a project where they develop sort of middleware, firmware, etc. for their quantum computers, and they collaborate with the Fraunhofer Focus to implement higher programming languages. We have collaborations between ITWM and Parity QC in another project, where they really focus on co-design questions, and then sort of continue that to build a library that goes all the way up to the end user to help sort of like distribute sort of optimization problems ideally onto the hardware. But since you asked me so much about this sort of collaboration between software and hardware, I want to sort of mention a different gap that we think we also should address: collaboration between software and the end user, the one that really drives the application. Because as much if you just focus on making your quantum computer available, then you forget about all this loose coupling that Christoph mentioned so nicely on his slides. We really need to make sure that the end user can use the quantum computer in their application. And that is something that we also strive to do with our funding projects. So it's always the research institution, solution providers, and end users that work together in a collaboration. And then these end users can really bring their problems, their use cases, and try and implement it. And hopefully by the end we get sort of some actual implementations in the companies that they then can use to apply quantum computing to solve their problems.
So you built the perfect bridge to my next question, I think. My next question
Welcome.
is really about the end users. And you also mentioned QUTAG, which is one of the big user associations in Germany, bringing together the big users from German industry and German economy. So how can we get the German industry incentivized and pushed to invest more in capabilities of developing software and really being ready to use quantum computing when it's ready. So I think, Valeria, you have a lot of experiences from partnership projects with industry stakeholders. What is your perspective on that? How can they bring more into the game from software perspective?
Well, I think they are bringing a lot already into the game by telling us about their use cases and sharing this information and letting us know what's important to them. And I think that's really what we need to know. And there are, I mean, especially in the public funded projects, there are these examples where the companies are trying to find use cases in their company which are suitable for quantum computing and develop an understanding what can be done, what can't be done. And and on the other hand, it helps us to see, like what is really the problem. I mean, what do we have to solve? And that's very helpful. And it depends a bit on the companies, but some companies, especially in chemistry, they are quite fit in quantum computing because they know this is a game changer for them. So, yeah.
I agree. I mean, they stomp very loudly for quantum computing software. I mean, historically, a lot of funding has gone into building hardware, and which is very important to retain digital sovereignty in Germany and in Europe. But we shouldn't forget the software train, and yeah, it's very good to hear from these companies that they stomp for it.
So link software to their domain knowledge and domain pathways.
Exactly.
I just can only agree. Nothing to it. Yeah.
Perfect. That's good to hear that we have an alignment here. So maybe we have heard a lot of very important points about the cooperation, current cooperations, future outlook at some point. So to conclude, what are the concrete next steps? Concrete next steps for German software industry users. We talked about users too, policymakers, researchers, here to advance the development and to get ready their frameworks for the future of quantum computing. So maybe you want to start, Valeria? Your final outlook?
Yeah, I mean, like, poor Johann, now he gets all my criticism, I guess, right? What should you do? But you were saying again, I mean, okay, we want to work together, we want to communicate between the funding agencies, and I love to hear that because I think that's really, really needed. I mean, like, also beyond ministries, that people are talking to each other, know what the other people are doing. And then the other thing is that maybe I'm talking a bit too much about open source here, and I know we should think about sovereignty, blah, 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 and so on and so forth. But, like, what you can learn from these approaches is really also this failure to fail. I mean, you can't say, okay, we have this one approach, and that's it. You need to have several approaches. I mean, I'm a particle physicist by training, and the point is, when there's an accelerator being built, you don't build one experiment, you build at least 2 multipurpose experiments and 2 others. And the 2 multipurpose are just to check each other, because it might be that one fails, one technology fails, one approach fails. And also when you have a result, to check each other's results. So you need this, and you need it both in hardware and in software. Yeah.
Yeah, my recommendation in general to the industry or to any enterprise, with the exception of software companies, would be to ask themselves the question whether potential quantum computing algorithm would or could be or should be part of their core competences, and they have to have it in-house for reasons of confidentiality and competitive advantage, or if they are confident and willing to contract that out. So it's a matter of transaction costs. If you are happy to, I mean, no one is doing HR system by themselves, but the engineering companies also are not doing design software, CAD software by themselves, but part of MES systems or so, or some logic, they want to keep in the company because of confidentiality reasons and competitive advantage. And they need to check whether part of that competitive advantage already is attacked or potentially attacked by quantum algorithms, or whether they can leverage that. And software companies simply need to look at my value chain and ask themselves the questions, where do they want to be and contribute to the value chain. I mean, if you say you stay out of that, that's also fine. And not many hardware vendors do not produce GPUs, graphical processing units. So that's a valid decision for software companies. And for those companies which are too small to do that strategic analysis, I think they need to listen, to stay tuned. Maybe interest groups or something like that, like Bitkom, and they just listen in. You don't need to be an early adopter everywhere, and no one is doing that, but you also do not want to miss the bus completely, like a software industry with cloud computing in Europe. So we completely missed that one, including Software AG, I openly confess that. So we watch that. So every half a year, you go to kind of events like that and realign your strategic assumptions. Maybe they are still correct, or maybe they get disproved. Yeah.
Final words.
I will take with me all the wish lists that are handed out today. We had some earlier today.
We didn't
but
talk about the money.
If I should say like concrete steps for policy, I think it's very important to demonstrate long-term support, because we heard it once, we heard it many times today. Quantum computing is not a sprint. It's going to take a long time before we actually get to really achieving any business advantage, to actually creating value. And I think the federal government and other actors need to stay in it for the long run. We at least identified as a topic that we want to do this. We have the action plan that came out earlier this year, which shows some promise for the next few years. But showing this long-term interest is, I think, really important.
I like this guy.
You could work with him, yeah.
Yeah, we can work with him.
Great. I like working with you too.
So thanks a lot for all the insights. A warm applause for this very interesting panel.
Thanks for the discussion.
Thank you for having me.